In this video, I'm looking at the solution to question 2 of the June 2011 Edexcel D1 paper, and the topic of the question is algorithms. We're asked first of all in the question to define a couple of terms, a tree and a minimum spanning tree, and then in part B to use Kruskal's algorithm to find a minimum spanning tree for the network shown in the figure. It says that the arcs, when we're doing this, we should list the arcs in the order in which we consider them, stating whether we are adding those arcs to our minimum spanning tree or not. We're also asked to draw the minimum spanning tree using the vertices in a diagram in the answer booklet, and to state whether our minimum spanning tree is unique and justifying our statement. So the first part of the question then is one of sort of definitions from bookwork. So firstly, a tree. We need to get some terms into here. It's a connected graph with no cycles. So those terms are what are being looked for here. So a connected graph and no cycles. So connected, all the points are joined together, but a cycle means that we don't have any loops within our within our diagram. A minimum spanning tree is obviously a tree which contains all vertices and it has smallest possible weight. We could say total weight. So we need to get those terms into there. The first one being that all vertices and the smallest possible weight. The second thing which is being looked for. The marking then was to give B1 for the definition of a tree, and then 2 B marks for stating all vertices and smallest possible weight in the second part of the question. We're then asked to go on and use Kruskal's algorithm to find a minimum spanning tree for the diagram, and also to draw the minimum spanning tree and to state whether it is unique or not. Now, I would suggest that we always in these questions, if you're asked to draw a minimum spanning tree, that you do it as you're doing part B of the question. It makes sense because it keeps track of whether you've got loops forming or not. So remember, the Kruskal's algorithm is the one where we're looking for the smallest arc to be added at any particular time. So we need to list these in order. The smallest one is from A to B, so we simply say that that one A to B is added. And then the next one is D to E, which is 12. So putting those in on my diagram, A to B and D to E. And looking around now for the next smallest one, it's actually B to C, which is 13. So that's okay. So from B to C, which is 13. And then we get to some that we're not going to. So the next smallest one is our AC and BD. So if we look at AC first of all, that would form a loop. So we're going to say AC is not added. But BD is okay. That's of length 14, so that one is going to come in. And then looking at the next one, BE is length 15. Well, we're not going to add that one because it would form a loop. So not BE. And then the next one is CE. And again, that would form a loop, and we can see that clearly on our diagram 1 that we're completing, so not CE. And then finally we've got a choice of either CF or EF. So I'm going to put in the EF one on my diagram. Now, the final part of the question, we've already obviously got our minimum spanning tree. The final part of the question, which says state whether the minimum spanning tree is unique. Part D, it's not unique because we could have used CF instead of EF. So we've got that choice there at the end. So there we are. That's the question complete. Let's just look at the way the marking for this was done. We had an M1 mark and then 2 marks, A1 for selections and A1 for the rejections in the correct sequence. A B1 mark for the minimum spanning tree, and then B1 for the justification that it was not unique. Well, that's the end of the solution to this question. You can find solutions to other questions at www.furthermaths.org.uk.